Welcome everyone in this video. In today's discussion, we will see about particle image velocimetry and tracer particle visibility. So let's start. Let's start with the particle image velocimetry. PIV express a vast field with varying techniques and data acquisition methods. However, the main goal is providing an optical method of low visualization flow optical method of flow visualization. The exact information obtained depends on which method is used with the new algorithms and approaches being discovered constantly. So the moral of the we can say that the PIV is generally their main purpose is to obtain to provide an optical method for flow visualization. Here he used new algorithms. It's depend on the methods. Here the PIV data can be obtained various methods, but generally they are these methods are depends on the algorithm which are we use an approach that we are using to obtain result or data. So there are generally two ways two ways to obtain data. First one is PIV and the second is particle tracking velocimetry. And the first one is a PIV particle image velocimetry and the other one is the particle tracking velocimetry. So let's see some of which can then which can then be broken down into many other methods based on how exactly the data was obtained and the processing done to said data. These both methods can be divided into subparts based on their methods they use to exactly what methods of you obtain data using methods, which methods they are obtain data. PIV measures the velocity field of fluid based on Eulerian Eulerian methods, where state location are observed over the time to determine the flow. So in the PIV is based on Eulerian method, while PTV tracking the movement of singular particles over time a Lagrangian approach. In PTV we use Lagrangian methods and in PIV we are using Eulerian Eulerian methods. This Lagrangian approach, this in the PTV, this approach provide a plot of particles movement and by relation information about the fluid flow. The both methods are using tracer particle. However, they look at them in different sense. Both the methods PIV and PTV both are using tracer particle to track the flow movement, but they both techniques are seen in a different way. If logs in a river, then let's understand it's how they both methods are looking differently. If log in a river are a representation of our seed particles, then PIV looks at the river and see the logs moving through it, determining how determining how the river flow based on this information, while PTV watches the movement of individual logs to obtain similar information, which lead to the assumption that tracking particles must be easily visualized. So in simple one, PIV focus all particles on a specific range or specific they consider all particle moving through the with the flow of fluid, but in the PTV here PTV generally focus on individual particles and this see an individual, and the basis on the individual particle he give information about flow of fluid, and this leads to the one assumption, that is the tracking particles must be easily visualized. Let's talk about visibility. Visibility being an important aspect of tracer particle is a given, but how those particles are visible is where difference can come out. Visibility is the most important aspect for tracer particle, because if we if particle don't have visibility properties, then how we can observe the tracer particle to find out the fluid velocity, velocity of fluid. So the visibility property is important. So there are first method where we can visualize the tracer particle. The tracer particle, there are two methods. Here we will discuss the two methods. First one is, in first method, tracer can be visualized if they block light from the reaching the visualization mechanism like eyes, camera, etc. In first method, we are seeing the tracer particle if they block the light source from the reaching visualization mechanism, essentially being visualized as a shadow. Here the particle is seen as a shadow. This method is known as a backlit shadowgraphy, where the flow is placed between an illumination source and a camera, allowing for the absence of light shadows caused by tracer particle to track. So through this method we are use the blocking the, here the tracer particle block the light source, and that's their shadow. After they block the light, they generate shadow, and that shadow will be the track, that shadow will be captured in camera or any other things which are we are using to track, and that shadow we can easily can see now through our eyes. And the second method, another approach to assuring particle visibility is using highly reflective spheres. Here on the second method we are using highly reflective sphere that will reflect in the direction of your camera, that setup the setup allowing them to appear as a dot of high intensity light of the illumination source used. So in other method, here we are using reflective, highly reflective sphere. When light source is incident on the light source is illuminate these sources particle, they reflect light, and the illuminated light will be captured through our camera. So the laser, here the laser are most commonly used as a illumination source for this form of particle visibility, as laser have high power, high collimation, and a relatively tight emission bandwidth. So the laser, through the laser light we are illuminated sphere reflective, we are illuminated particles, tracer particle, and that will generate reflective light, scattered light, and this light can be captured through their different light will be captured through our camera to measure the flow of fluid. Let's see some here the also let's see the some tracer particle which are emit light. Some tracer particle can emit their own light, which allows them to be an easily distinguishable wavelength from the illumination source, which can often flood the visualization area. So the some tracer, we have some tracer particle which can emit light, and that tracer particle are generally using second method, where we are using one illumination source to illuminate light from this tracer particle, and that tracer particle will generate different wavelength light, and that different wavelength can easily we can easily distinguishable from the light source. One of this would be fluorescent sphere. One of the example would be fluorescent sphere, which when excited by illumination source will emit a different wavelength of light. This fluorescent will be illuminate source that is fluorescent sphere, where emit different wavelength when illumination source is when we illuminate through the illumination source. This allow the wavelength of light used as your illumination source to be filtered out, providing an image with just light from the tracer particle. Here we allow the wavelength of light used as a illumination source to be filtered out, providing an image with the just we are just general we are what we will do here is we filter out illumination source wavelength and particle tracer particle emitted wavelength, light source or light emitted wavelength. Then this when we find difference between these wavelength, we can easily track this, visually capture the tracer particle. Another is a phosphorescent sphere fall into category similar to fluorescent particle, as phosphorescent emit light similarly to fluorescence. However, the second example would be phosphorescent spheres. However, fluorescence emit over a long period of time. Another significant difference of the fluorescent material is their unique temperature variation, which allow for them to be used as a form of temperature sensor. So, with the both PIV and PTV having their strength and weakness, there is no clear superior method. However, with the advance in the technology, PET is becoming more feasible and thus may overtake PIV method due to its ability to provide greater data varieties. But visibility options also have their unique aspect that ensure their necessity in a specific area. Shadowgraphy is gaining traction in area due to its reduced cost requirement and easy of use, because when we use shadowgraphy method, this will reduce in terms of costs, and it is usually easy to use. And where we will, if we think of another method, second method, where is so second method is known, second method where we required very expensive setup. That's why the shadowgraphy method is can be favorable and prefer if we have very limited budget for our experiment or setup. So while fluorescent tracer remains as an ideal option for application where shadowgraphy cannot quite meet the necessary criteria, if you want precise information or very accurate information, or very highly, if we use very highly advanced technology, then we should go for the fluorescent tracer particle. Otherwise, if we are just try to do some basic experiment, then we should go for the shadowgraphy. So this is all about tracer particle and image velocimetry, tracer particle visibility. Thank you.